Moving quite along, let's go to number 16. If there are 4 marbles are drawn at random from a bag containing 6 distinct silver marbles, so that means that there of those 6 silver, maybe one has flecks, one has circles on it or something, but they're all different. And you have 5 distinct gold marbles, so that's the key. They're all distinct. How many different draws are going to have 2 marbles of each color? Okay, so let's think about this. We're going to draw 4, so our R is 4 technically, and we have a total of 6. It looks like N is a total of 11 marbles, the 6 silver and the 5 gold. Okay, so how many different draws are going to have 2 marbles of each color? Well, let's think about it. If I for sure need 2 silver and 2 gold, so out of, let me think about it, I'm going to write it like this. Out of the total of 6 silver, I need 2 of them. So combination of the 6, I'm going to select 2. And then of the total of 5 gold marbles, I want to select 2. Okay. So here are my 2 kind of my subtasks. My subtasks being I want to select 2 silver and 2 gold. My overall task is trying to get 4 marbles. But specifically, I want the subtask of 2 silver and 2 gold. And remember, back on the very first thing, multiplication principle says the total number of ways this can be done is by multiplying it together. So it's a combination of the 6 silver, we're going to pick 2, and of the 5 gold, we're going to pick 2. Or if we use our calculator, what that's going to be is then 6 NCR2 times 5 NCR2. And what comes out after we look at all this is 150 different ways that I can pick 2 marbles of each color from this bag. Okay. So let's go on to the next part. So I really didn't have to use 11, the grand total, but I just had to break it down to each individual portion that it kind of described for us. All right, part B, no more than 1 silver marble. So no more than 1 means I can have 0 silver, or I could have 1 silver, right? So let's talk about this. We have or, so we're talking about 2 scenarios here. This is where I'm going to finally have a little addition going on, but it's going to be multiplication within the addition. So how many ways can I get 0 silver? Let's talk about that. Well, if I don't want any silver, you can think of it as the combination of the 6 silver, I want 0 of them, and then obviously then of the 5 gold, I need all 4 coming from the 5 gold, because my goal is to pick 4 marbles. Okay, now that's one where I have 0 silver. The other way I can have it is 1 silver. So combination of the 6 silver, I want to pick 1, and that means then the other 3 have to come from the 5 gold. So I could either get, if I have no more than 1 silver, I can either get my options coming from this first one, or in math means plus, or coming from the second one. And truthfully, guys, if you left your answer like up here in part A like that, I am 100% good to go. I agree, that's your answer. You don't have to plug it in your calculator. And same thing here with part B. If you want to box that up and call it done, that's fine. I'd rather you spend your time more on how to formulate this than plugging them in your calculator. So that right there could be the answer for part B. If you want to go though, if you want to check just to get practice, let me plug it in the calculator real quick for y'all. You'll get 5 options coming when you have 0 silver, and you'll get 60 options when you have 1 silver and 3 gold. So it's a grand total of 5 and 60, so 65. If you want to double check with me. Okay, let's go on to example number 17. And with this one is where we're talking about going, up to Las Vegas and playing some hands with cards. You have 5 cards that are going to be drawn from a 52 card deck. How many different hands are possible? Okay, well, how many cards are you pulling from? We've got a deck of 52 cards, and we want to pull just any 5. So right here, the answer is just going to be a combination of those 52. I want to pick 5. Simple as that. And the reason why I'm doing a combination is because, think about it, when you have 52 cards, does it really matter the first one that you pick up to put in your hand, as opposed to the second, the third, the fourth, or the fifth? In general, what you're doing when you want to play poker, you're wanting to play all 5 cards together as a whole, as a team. So it really doesn't matter the first one picked up or the second one picked up. So definitely here we're talking about a combination. Okay. So going on part B, how many of those 5 cards are going to only contain spades? We should probably take a second here, and just for some of y'all that aren't familiar with how deck of cards work, you know, you have 52 total cards. We have 26 that are black, and we have 26 that are red. We have 4 suits. You know, the 4 suits being the spades, the hearts, the diamonds, and the clubs. And then we have 13 what we call kinds. The 13 kinds are your 1s, your 2s, your 3s, all the way up to the jacks, the queens, the kings, and the aces. So there's 13 kinds of each of the suits. Okay, because you have the spades of jacks, the hearts of jacks, the queen and the diamonds and the clubs of both of jacks. Okay, and then the only other thing I could think of that we might talk about are face cards. The face cards are the cards that actually have faces to them. So the jack, the queen, and the king. There are 3 per suit, or a total of 12 in the whole entire deck. Okay, so just something to keep in mind real quick. So in part B, when we say contain only spades, well, if there are 4 suits and 52 cards, that means there must be 13 total spades, 13 hearts, 13 clubs, and 13 diamonds. So out of those 13 spades, I just need to select 5. And that'll tell you the combination of that combination will tell you how many ways that how many cards counting will have exactly 5 spades. It's going to be very small, very hard to get just all in one suit. All right, part C, contain cards of any one suit. Okay, so here, the difference between B and C is they're the exact same thing, so it's definitely going to be a combination of 13 take 5. But the difference with B, it said we knew it had to be spades. With C, it says we don't know. It just can be any one of the suits. Well, how many suits are there? There are 4. So what we're going to do is a combination of 4 take 1 tells you how many ways you can pick one of the 4 suits. And then once you've picked one of the 4 suits, then you're going to pick 5 cards from its 13. Okay? If you kind of want to go back up to part B, since it said it had to be spades, you can almost say then it'll be multiplied by a combination of that 1 suit of spades, I want to pick that 1 suit. Well, a combination of 1 take 1 is 1. So there's not much difference there. But okay. So 4 take 1 chooses one of the suits, and then 13 take 5 picks 5 cards from that suit. Now, let's go to part D. We want to draw 5 cards. Specifically, in our hand, we want to have for sure 3 kings and 2 tens. Okay, well, how many kings are there total in the deck of cards? Well, there are 4 kings, and we need 3 of them. How many tens are possible in a deck of cards? Well, there are 4 tens, and we specifically want 2 of them. So together, by multiplying, that'll tell me the number of ways how many hands will have specifically 3 kings and 2 tens. Okay, and let's go to part E. How many of these 5-card hands contain 3 cards of one kind? So we're not really specified here, that we're generalizing now. You know, up in part D, we had specifically 3 kings, 2 tens. Now instead of having just 3 kings specifically, it's just 3 cards of any one of those kinds, and then 2 cards of another. Okay, so let's think about this for a second. How many kinds do I have? Well, I have 13. So what I'm going to do is, of those 13 kinds, I'm going to select 1. So what I've done is I've narrowed them down. Let's say of those 13 kinds, I've selected the 5s. Okay, what I need to do is select 3 of them. So of the 4 5s that are in the deck, I need 3 of them. Okay, so that's how I'm going to get 3 cards from one kind. Now, so multiply. If it said or, then I would add, but and means multiply. I need 2 cards of another kind. Well, I've already used up one of my kinds when I selected 3 of it, so now I have 12 kinds left to choose from. I'm going to pick 1 kind from the 12 that remain, and of the 4 cards from that kind, then I want to select 2. Okay, so let's think about this. What it's saying is then, let's say, of the 13 original kinds, let's say I select the queens. Well, there are 4 queens in a deck, and I need 3 of them. All right, now the queens are out of the way, so now I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, King, Ace. So there's only 12 kinds to choose from. I'm going to pick one left over from that group, and of the 4 cards that come out, I need 2 of them. And there's your answer. So this is a good example of one of those. I'm like, you don't have to plug that in your calculator. Just stop right there and just box it up and call it a day. Okay. Let's go to number 18. In the NBA Finals, 2 teams compete for the title, which will be awarded to the first team to win 4 games. In how many ways can the finals be completed? Okay, so definitely a scenario we're all common with. We all watch the NBA Finals. So you have 2 teams here, and it has to be the best of. They're trying to win 4 games. So let's think about it. Is it really out of 4 games? They just need to win 2? Not so much. It's whoever wins 4 games wins the whole tournament. So it's really a best of 7, if that makes sense, because I could have team 1 win the first 3. They can win 1, 1, 1, and then all of a sudden the second team wins, and they win the next 3. But see, so far nobody's won their 4th game. And so finally, whoever wins this last one right here is the one that's going to win the full tournament. So really, this scenario is a best of 7 scenario. Okay, so it looks like basically is out of these 7 potential games, these pairings, where they face off against each other, whoever can win 4, their goal is to win 4. Okay, and that's what we're talking about it. We're narrowing it down because our N is going to be 7, our R is going to be 4. Because of the 7 games, what we're trying to do is see how many ways can they win. How can we distribute out the 4 different possible areas so that they can win? So it's going to be a combination. Let's see, NCR, if you want to write it like that, 7, 4, if you want to plug it in your calculator. Or just in general, if you don't want to use your calculator, it's just going to be a combination of 7 take 4. And whichever way you choose to do is going to give us an answer of 35. So there are 35 different ways that the finals can be done, in the sense of, like I said, team 1 could win the first 3, then team 2 can win the next 3. Or it can alternate team 1, team 2, team 1, team 2, all the way down. Or team 1 can win all first 4 flat out, and there won't be games 5, 6, and 7. Or team 2 can win the first 4, and there's no need for games 5, 6, and 7. So what this does is account for all the different ways, to whether it takes all 7 actual games or pairings, or it even just takes the first 4. That's going to tell you how many different ways the NBA Finals can be won. Okay, well, I'm going to stop this video for a second, and we're going to go on to part 2 of this. What we're going to do in part 2 is talk more on probability now.